I think already you have started working out. As I have told earlier, you take your copy and pen and start with me. No difficulties there. We have used here the derivative of x to the power n. We have to find the value of dy dx at x equal to 2. Therefore, dy dx at x equal to 2. For that, we have to put here in place of x 2. Good morning. Welcome to btosacademy. Welcome to my maths class. Today, continuation class of differentiation. On the board already I have written 5 sums. I shall work out these sums serially. First of all, sum number 1. Given y is equal to root x plus 1 by root x. Let us write in the form x to the power n, x to the power half plus x to the power minus half. Differentiating with respect to x, left hand side will be dy dx, ddx of x to the power half plus ddx of x to the power minus half. U plus v form, therefore du dx plus dv dx. Now we apply the formula. ddx of x to the power n is equal to n x to the power n minus 1 half x to the power half minus 1 minus half x to the power minus half minus 1 half x to the power minus half minus half x to the power minus 3 by 2. Now we have to prove this one. For that we multiply this result by x. X dy dx is there. Therefore 2 dy dx is equal to 1 by root x minus x to the power minus 3 by 2 means x to the power minus 1 into x to the power minus half. That can be written as 1 by x root x. Note this step. On the right side you can simplify this one and write here the simplified form. Therefore, now I multiply to get this 2x dy dx. 2x dy dx is equal to x into 1 by root x minus x into 1 by x root x. X is cancelled here. This will be root x minus 1 by root x. Now we add this one. Therefore 2x dy dx plus y, that means left hand side, is equal to root x minus 1 by root x. Now I put the value of y, root x plus 1 by root x. These two cancelled, therefore this becomes 2 root x. Therefore, final step 2x dy dx plus y is equal to this root. I think already you have started working out. As I have told earlier, you take your copy and pen and start with me. No difficulties there. We have used here the derivative of x to the power n and got the result. Next I shall move to sum number 2. For that I have I think you have copied or you have solved yourself, and for checking you see the steps. Given y is equal to sec x plus 10x. Therefore, or you mention this differentiating with respect to x dy dx ddx of sec x plus 10x that will be equal to ddx sec x plus ddx 10x. Always keep in your mind, we are applying here the theorem ddx of u plus v, where u, v are functions of x, is equal to du dx plus dv dx. Now, ddx of sec x 10x, ddx of 10x, already we have derived all these sec square x. Now we see sec x is common factor 10x plus sec x. We have got dy dx, therefore dy dx is equal to this one. Now we simplify this one, sec x 10x plus sec square x. Now we have to prove this one. Actually earlier I copied wrongly, but the sum will be this one, not 2y dy dx. This will be 2 dy dx equal to 1 plus y square. Therefore, 2 dy dx is equal to 2 sec x 10x plus 2 sec square x. Now we simplify this one. We keep this result up to this. Now 1 plus y square 1 plus sec x plus 10x whole square. Actually we are calculating the right hand part, and we simplify 1 plus 10 square x sec x tan x. Now 1 plus tan square x means sec square x. 1 plus tan square x is sec square x. Then this sec square x, that means 2 sec square x plus 2 sec x tan x. Now we see this right part and this one are same. Therefore, from 1 to dy dx is equal to 1 plus y square root. Sometimes we cannot reach the right part directly. In that case, we calculate the left hand side up to some stage. After that, we calculate the right hand side or right part, and we shall see both will be same. Then from these two, we conclude this one. Therefore, the sum is solved. Now we move sum number 3. For that, I am to rub. Given y is equal to 1 minus sin x by 1 plus sin x. We have to prove this result. First of all, we see that this is a trigonometric function and this can be simplified. First I simplify this one. Now 1 minus sin x by 1 plus sin x is equal to, first of all, minus sin x, that can be written as 2 sin x by 2 into cos x by 2. 1 is sin square x by 2 plus cos square x by 2. I write that. Therefore, the numerator becomes sin square x by 2 plus cos square x by 2 minus 2 sin x by 2 into cos x by 2, which is a perfect square. Now I write the denominator also in that way. That means numerator is cos x by 2 minus sin x by 2 cos x by 2 plus sin x by 2 whole square. Therefore, y is equal to square root of this one. Therefore, y will be equal to cos x by 2 minus sin x by 2 by cos x by 2 plus sin x by 2. Since the expression within the square root symbol is 1 minus sin x by 1 plus sin x, we can express that expression as a square form, therefore y will be this one. Here we keep in mind the principal range of the angle where cos is greater than sine. That is why I have written in this form. And this is, if I divide both numerator and denominator by cos x by 2, we get this one. This one 1 minus 10x by 2, 1 plus 10x by 2. Therefore, y is equal to, the 1 means 10 pi by 4 minus 10x by 2, 1 plus 10 pi by 4 into 10x by 2. Means tan alpha minus tan beta by 1 plus tan alpha tan beta. That means tan of pi by 4 minus x by 2. Now we can find the derivative of this one. Therefore, dy dx is equal to, already I have discussed in the earlier class, we are using here chain rule. First of all, tan u form, that means 6 square u into du dx, ddx of pi by 4 minus x by 2. I am to rub. Therefore, dy dx is equal to derivative of pi by 4 minus x by 2. Derivative of pi by 4 will be 0 minus ddx of x by 2 means half, minus half rather. Therefore, it will be minus half 6 square. I write 6 square form 1 by cos square pi by 4 minus x by 2. Now we have to simplify this one. Minus half into 1 by, this is cos of alpha minus beta form, cos pi by 4, cos x by 2, cos pi by 4 is 1 by root 2 into cos x by 2 plus cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. 1 by root 2 into sin x by 2 whole square, that is equal to minus half. We take 1 by root 2 outside, therefore 1 by half is outside, cos x by 2 plus sin x by 2 whole square. Now this are cancelled. Now this one minus 1 by this is cos square x by 2 plus sin square x by 2 plus 2 sin x by 2 cos x by 2. Now from this, therefore dy dx is equal to minus 1 by, this is sin x by 2 plus cos x by 2 1 plus this one 1 plus 2 sin x by 2 into cos x by 2 means minus 1 by 1 plus 2 sin theta cos theta, that is sin 2 theta sin x. Therefore, taking on the left side we get dy dx plus 1 by 1 plus sin x is equal to 0 root. A bit longer method. Actually, we have simplified in the initial stage 1 minus sin x by 1 plus sin x, then got the value of y in a simplified form and got y equal to this one. After that, I have adopted trigonometrical way, but getting this result, we can also find the result as it is in the form u by v. We can apply that theorem of derivative when it is in quotient form. Now I show this so that you can feel easy. This is of the form dy dx, y equal to e by v form. Therefore, dy dx will be equal to, I have told you to write v square first, that means cos x by 2 plus sin x by 2 whole square v square. Now I rub this right part. Numerator will be cos x by 2 plus sin x by 2 into ddx of cos x by 2 minus sin x by 2 minus cos x by 2 minus sin x by 2 into ddx of cos x by 2 plus sin x by 2. This will be here. Now we simplify. Denominator cos x by 2 plus sin x by 2. Numerator cos x by 2 plus sin x by 2 into derivative of this one. In the earlier class, I have deduced derivative of sin mx, which is m cos mx, derivative of cos mx, which is minus sin mx into m. So it will be minus half sin x by 2 minus half cos x by 2. Cos x by 2 means cos half into x. Here m is half. Therefore, this will be the derivative minus cos x by 2 minus sin x by 2 into derivative of this one minus half sin x by 2 plus half cos x by 2. Now minus half are there. We take that outside first, then half, we put second brackets, cos x by 2 plus sin x by 2. Here minus half is common, therefore after taking minus outside, it will be cos x by 2 plus sin x by 2 whole square. That means cos square x by 2 plus sin square x by 2 plus 2 sin x by 2 cos x by 2. Then if I take just half is out already, I have taken outside. This is cos x by 2 minus sin x by 2 whole square. That means it will be cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 into cos x by 2. And second bracket is closed and denominator is, if I take the expanded form, it will be cos square x by 2 plus sin square x by 2 plus 2 sin x by 2 cos x by 2. Cos square x by 2 plus sin square x by 2 is equal to 1. Therefore, finally it will be 1 plus sin x. Now, we simplify. Minus is outside, therefore dy dx is equal to minus half into. Now we see cos square x by 2, it will be plus cos square x by 2, that means 2 cos square x by 2, sin square x by 2, also sin square x by 2, 2 within brackets sin square x by 2 plus cos square x by 2 plus 2 sin x by 2, and this will be, after taking minus sign common, these two will be cancelled. Therefore, finally we get this one, and this is 1 plus sin x minus 1 by 1 plus sin x. Therefore, dy dx is plus 1 1 plus sin x is equal to 0 proved. Now sum number 4, y is equal to root over 2x minus root over 2 by x plus x plus 4 by 4 minus x. We see y is equal to this one. First of all, I write in the simplified form like this. Differentiating with respect to x, dy dx on the left side and the right side c into fx form. Therefore, derivative will be root 2 into ddx x to the power half minus root 2 into ddx x to the power minus half plus. Now it is of the form u by v. Therefore, we have to apply here 4 minus x whole square 4 minus x into ddx x plus 4 minus x plus 4 ddx 4 minus x. Now this becomes root 2 into half into x to the power minus half minus root 2 into minus half x to the power minus half means minus 3 by 2 plus this one 4 minus x whole square 4 minus x derivative of x plus 4 ddx of x that is 1 ddx of 4 that is 0. Therefore, this will be 1 minus x plus 4 derivative of 4 minus x derivative of 4 is 0 as it is constant and ddx of x that is 1 that means finally it will be minus 1. I just multiply with this symbol and write it this one. Therefore, this is 1 by root 2 into x to the power minus half plus 1 by root 2 x to the power minus 3 by 2 plus 4 minus x whole square. X cancelled here, therefore 8. This is dy dx. Therefore, dy dx is this one. We have to find the value of dy dx at x equal to 2. Therefore, dy dx at x equal to 2. For that, we have to put here in place of x 2. Therefore, 1 by root 2 into 2 to the power minus half plus 1 by root 2 into 2 to the power minus 3 by 2 plus 8 by 4 minus 2, 2 square means 4. Therefore, we get 1 by root 2, 2 to the power minus half means root 2 plus 1 by root 2. 2 to the power minus 3 by 2 means 1 by 2 root 2 plus 2. Therefore, this is half plus 1 by 4 plus 2 . Finally, we get dy dx at x equal to 2 is equal to 2 whole 3 by 4. Answer. Sometimes you have to calculate like this. There may be some complications, but you have to be very much strong to simplify that. Finally, we get the result of dy dx at x equal to 2, which is 2 whole 3 by 4. Now we come to the fifth sum. For that I rub this one. Given fx is equal to this, we have to find the value of f dash 1. For that we need fx. These are the given values. First we use these values or use these relations and we will get 3 equations involving ABC. Now f2 equal to 1. Therefore, putting x equal to 2, 4a plus 2b plus c is equal to 1. If 3 equal to 6, we have to put here x equal to 3, 9a plus 3b plus c equal to 6, then and f minus 1 is equal to 10. Now we have to put here x equal to minus 1. It will be a minus b plus c is equal to 10. Thus we get 3 equations, 1, 2, 3. Now we have to solve these 3 equations to get the values of ABC, so that we shall get fx. Now 1 minus, if we want to cancel c, we just subtract equation 3 from 1. What we get? we get a plus b equal to minus 3. Next we take these two, 1, 2, 2 minus 1, 9a plus 3b plus c is equal to 6, 4a plus 2b plus c equal to 1, 5a plus b is equal to 5. I call it number 4 and this is number 5. Now we consider these two, 4 and 5. 5 minus 4, 5a plus b, 5, and this one, a plus b is equal to minus 3. We subtract 4a is equal to 8, therefore a equal to 2. At last we have got a equal to 2. Now we put that value in 4 or in 5, putting a equal to 2 in 4, 2 plus b is equal to minus 3. From that b equal to minus 3 minus 2, that is minus 5. We have got the values of a, b, then we put those values in 3 or any of 1 to 3, putting a equal to 2, b equal to minus 5 in 3, 2 plus 5 plus c equal to 10. From that c equal to 10 minus 7 equal to 3. Thus we have got the values of a, which is 2, b minus 5, c equal to 3. We have found the values of a, b, c. Therefore we know fx. Therefore fx is equal to 2x square minus 5x plus 3. Finally, we have got the function fx is equal to 2x square minus 5x plus 3. Therefore, f dash x will be equal to derivative of the right side. 2 derivative of x square means 4x. 5 ddx of 5x, that is equal to 5, and ddx of 3 is 0. Therefore, f dash is equal to 4x minus 5. We need f dash 1. From that, f dash 1 is equal to 4 into 1 minus 5, that is equal to minus 1. Therefore, the value of f dash 1 is minus 1. Actually, in this case, a, b, c are unknown first, and we have given the values of f2, f3, fc, f of minus 1, putting x equal to 2, then x equal to 3, then x equal to minus 1, and simplifying, we have got the 3 equations involving a, b, c. That means we have to first get the values of a, b, c. For that we have solved these 3 equations and got the values of a, b, c. A equal to 2, b equal to 5, minus 5, c equal to 3. And putting those values of a, b, c, we have got fx. After that we have got f dash x, and from that we have got f dash 1, which is minus 1. Already we have learned, or I have discussed, how to find the derivatives of a given function with respect to the independent variable. Now, the question is why we need derivative or differential coefficient of a given function. That means meaning or interpretation of derivative. First, y is function of x. Already it is discussed. Fx is taken to be single valued. Now, corresponding to the change of x, that is x takes the value x plus delta x, and corresponding changed value of y is y plus delta y. That means delta x change in x, delta y change in y. Next, we have considered the ratio or quotient delta y, delta x. Now, if we write this, that means quotient of change of y to change of x. This is the rate measure. Rate measure, that means that gives us the rate of change of y with respect to the change of x. Now we have different meanings of dy dx. First, we take geometrical meaning. Here, one thing, this is the average change, and when the change of independent variable is very small, then we call this ratio or this quotient as dy dx. Since change in independent variable is very small, we call this is instantaneous change. This is the rate measurer or rate measure. Then we consider geometrical meaning. Say y equal to fx is a single valued function. We can take this diagram. Let y equal to fx be the curve. Let PQ be 2 points on the curve having coordinates. This is x, y, and this is x plus delta x, y plus delta y. 2 neighboring points. Now we drop perpendicular from the straight line L cuts the curve at P and Q points, where PQ are points on the curve, also they are lying near to each other. Now after dropping perpendicular from PQ on the x-axis, say PL and QM, then PR perpendicular on QM is drawn, so that we get triangle, rather right triangle PQR. Now if this straight line make angle theta with the axis, then from geometry we see this angle RPQ will also be theta. Therefore tan theta will be tan of angle R PQ, that is equal to, with respect to this angle, tangent, that means RQ by PR. Now RQ is equal to MQ minus MR. And PR, this will be a rectangle, therefore PR will be equal to ln, that means OM minus OL. After putting these coordinates, we shall get this is equal to delta y by delta x. Now if Q approaches P, when Q approaches P along the curve, then delta x tends to 0. And this angle will be something other angle, which is made by this straight line L, and this straight line becomes tangent. You see, when Q approaches P, that means the straight line will be like this. This straight line will be a tangent. I write here. Then L will be tangent to the curve. Therefore, making angle psi with the x-axis. Therefore, limit delta x tends to 0, delta y by delta x is equal to tan theta will be tan psi, and this is dy dx. Thus we get the geometrical meaning of derivative dy dx is equal to tan psi. That means dy dx is the tangent of angle psi which is made by the tangent to a curve y equal to fx at the point P xy. Thus the geometrical meaning is slope of the tangent at P to the curve to the curve. Let us repeat. Therefore, the geometrical meaning of dy dx is the slope of the tangent to the curve y equal to fx at the point x, y.